Let's talk about my favorite T SQL operator. Welcome to this video on the apply operator. My name is Kevin Fiesel, and I am the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. I have spent a suspiciously large amount of my career extolling the virtues of the apply operator. It's a versatile bit of T SQL functionality that has a very particular set of skills. Skills it has acquired over a very long career. Skills that make it a nightmare for... Wait, wrong topic. Over the course of this series, we are going to see several use cases in which the apply operator might be superior to whatever you're using right now. Unless you're actually using apply, in which case, good on you. But just in case you haven't heard me ramble on for hours about how great apply is, join me in the classroom so I can ramble. Though not for hours. Probably. The apply operator. Where to begin? Let's, I suppose, start at the beginning. The year is 2005. SQL Server 2005 barely meets its release date. Microsoft packed SQL Server 2005 full of goodies, and if you spent a lot of time installing the SQL Server documentation from CD, or even using the mighty power of books online, you might have seen a paragraph or two about this apply thing. Or maybe you picked up one of those SQL Server 2005 books in your local bookstore. Flip through the pages and you get all kinds of information on hot topics like database mirroring, common table expressions, the pivot and unpivot operators, try catch, window functions, etc. In fact, let's pick on a personal friend of mine, Jim Duffy. Jim is a great guy who just happened to write about SQL Server 2005 in Code Magazine prior to its release. Here is an online copy of what Jim wrote in Code Magazine back in December of 2004. As we scroll through it, we'll see quite a few useful bits of T SQL syntax, including updates to the top clause, the output clause, and more. But notice what he did not include? That's right, there was nothing in this article about the apply operator. And I'm not picking on Jim, even though I totally would do so in person. In general, anything you read from this time frame will, at best, briefly mention apply and then move on to the more interesting items. It wasn't until several years later that smart people came up with very clever uses of apply to solve a variety of problems. With that historical context in mind, let's briefly cover what the apply operator does before going into a demo and seeing the original use case for the function. What the apply operator does is that it allows you to execute a function against each record of a data set. Let's suppose we have a table with some records in it. For each record in this table, we want to execute some function. The function gives us 0 or more records back for each execution. This is where I need to make an important distinction in apply because there are actually two variants, cross-apply and outer apply. Cross-apply is semantically similar to, but not exactly the same as, an inner join. In other words, with cross-apply, we are going to eliminate any rows whose function output is the empty set. We would then return the combined output as a new result set. And by the way, if the function emits more than one output row, each output row joins back with the original left-hand side row, so we get that many records back in our final result set. That's how it works for cross-apply. Now let's talk about how outer apply works. Outer apply is semantically similar to a left outer join. In other words, even if the function emits 0 rows, we still keep the original left-hand side row and pad any missing columns with null. You might be asking yourself, if we have semantic matches for inner join and left outer join, what about right outer join, full outer join, and cross join? The answer is, there is no representation of apply for any of those. The reason for this is in the definition of a function. Remember that a function is a mapping that takes an input and emits an output. Our input is the left-hand side. Our output is the right-hand side. The equivalent of a right outer join, or the right half of a full outer join, would be that I could take an output record and invert that function, finding all of the valid inputs for this particular result. That's conceptually possible in certain mathematical functions, but not when you're talking about SQL Server datasets. So those two are right out. And a cross join would suffer from a similar problem. You would need to find the entire range of viable outputs for the function call and then merge them together with your inputs. Not a great idea. This is the concept. Now let's go to a demo and see the original use case for the apply operator, dealing with table-valued functions in SQL Server. Here we are in Visual Studio Code, where I'm going to demonstrate a few things. I'm also trying out the MS SQL extension for VS Code, given that Azure Data Studio will, sadly, not be with us for too much longer. Let's kick things off by querying a dynamic management view called sys.dmExecConnections. This is a rather useful DMV, as it tells us what is going on right now on our SQL Server instance. I have quite a few entries in this result set, but for the purposes of this demo, I don't actually care about the details in depth, just the shape of the DMV. As I scroll through the result set, I can see some interesting information, but not the most critical bit. What query is actually running for the session? Or if the session is idle, what was the prior query that ran? I can't get it from the DMV itself. I can, however, get it from a dynamic management function called dmExecSQLText. Specifically, this function expects a SQL handle. That is a binary pointer that is internal to SQL Server. Fortunately, I happen to have one of these in the column named Most Recent SQL Handle. As you can see here, some of these rows have values for Most Recent SQL Handle, and others have null, meaning that for whatever reason, we don't have the text for the most recent query. So that I don't waste anyone's time, I will state that there is no way to perform an inner join on this dynamic management function and return the query text for each row in dmExecConnections. Inner join simply doesn't work when you have functions containing parameters. Instead, this is the domain of cross-apply. If I highlight and run the second query, we can see some results. For each session, we have the number of reads, number of writes, and the text of the last query that ran on this session ID. This is a very useful outcome for database administrators, as now we can see who's doing what on our systems, and cross-apply enabled it. The next question is, what is the difference between cross-apply and outer apply? In the introductory segment, I mentioned that cross-apply is semantically similar to an inner join, and outer apply is semantically similar to a left outer join. We saw the results when running cross-apply. I got back one row per row in dmExecConnections that has a value for most recent SQL handle. But what happens if I switch this to an outer apply? Well, I happen to have a variant of this query ready for us, so let's run it. The only thing I changed was switching cross-apply to outer apply. Running this query, we can see many more rows come back, and the newly appearing records have null in the text column, just as the prophecy foretold. Now, one other bit of fun is that we can tweak what we send into one of these functions, and apply will handle it just fine. Scrolling down to the next query, I have a case expression inside of the function call, stating that if the session ID is 53, I'd like to send null instead of the most recent SQL handle. Let's run this, noting that we are still using outer apply. When we pass in null for session ID 53, we can see that the returning text is null, not the string that we would have expected given session ID 53's most recent SQL handle. And if I go one step further, I can change this outer apply to a cross apply. Before I run the command, I will state that I expect session ID 53 to disappear from the result set altogether, as the dmExecSQLText function will emit null instead of a value. Running the query, we see that this is exactly what happens. Now let's move on to the next script, which handles a user-defined table-valued function. To be clear, I don't like user-defined table-valued functions. SQL Server does a poor job of optimizing these functions, and so I prefer inlining this kind of code whenever possible, as my focus tends to be on making SQL Server run faster, and this is typically low-hanging fruit. Nonetheless, I do want to demonstrate the concept to you. Let's create a function and call it getPickerDetails. This takes a person's ID and returns information on that person. In the Wide World Importers database, pickers represent the people who are pulling inventory items to fulfill customer orders. We'll create the function, and then there's a quick example of how to use it. We can pass in a person ID, like 3, and get picker details. We see that this picker is Hudson Onslow, who is an employee and a salesperson. Now let's take a peek at some of the orders in the orders table. Looking at this table, we can see that the fourth column represents the picked by person ID. Some of these records have values for who picked the items for these orders, but not all orders have pickers. We can take a look at how cross-apply and outer-apply handle this information. I'll start with outer-apply. In this query, I drive from sales.orders, and for each of the top 50 rows, call getPickerDetails, sending in the orders picked by person ID. Running this query, I get back my results. When there is a person, we get that person's details, just as we see for order ID 4. When there is no picked by person ID, we still get the order back, but don't get any information on the person who picked the items. Let's switch to cross-apply. If I run this query, we can see that it too returns 50 results, but these are quite different from the first set. Now, we keep scanning through the orders table until we find 50 results with a picked by person ID. I'm going to create a second function here. This one takes in an order ID and then queries the order lines, trying to determine if the total price is at least $100 US. If so, we return the total sales price. Otherwise, we emit null. Let's create this function and then move to the next step. In this step, we're going to apply the getExpensiveOrderDetails function. We can see that for each of our first 50 orders, we get back an order price. Either that order price is above $100 USD, and we see it, or it was below $100 USD, and we see null instead. So what happens if we switch this to a cross-apply? Will we skip orders like order ID 3, which has a value under $100? And will we get back 50 total rows? Let's run it and find out. Oh ho ho, so you thought you knew how applied worked, didn't you? In this case, we actually get back a null for order ID 3. Cross-apply emphatically did not eliminate those low price records. The reason goes back to our understanding of how cross-apply works. For each element on the left-hand side, we call the function. Then, if the function emits at least one row, we stitch these together. Well, this function actually is emitting a row. It's emitting a row with a single column called order price. In that row, we have a null stand-in for order price. Restating this, we have one row, and its single column has null as a stand-in for the value. Cross-apply only filters out rows on the left-hand side with no row on the right-hand side. There is a difference, even if it's subtle. Let's alter the function a bit to test this out. Now, getExpensiveOrderDetails returns the order price of our order ID having a sum of quantity times order price of at least $100 US. You might say to yourself that this query is doing the same thing, but it's not, and I'll prove it. The first step is to run our outer apply operation again. Just as before, I get 50 rows back, representing the first 50 orders. If the order price was under $100 US, I would see a null for the order price. This looks to be the same as before. But now let's run cross-apply and see if it's any different. And in fact, it is. We no longer have order ID 3 in the result set. That's because our new function does not return any rows if we do not match the criterion in the having clause. If the order price is less than $100 USD, we emit 0 rows back, and thus cross-apply filters the way we would expect it to. That was our basic introduction to the apply operator. Now, I will note that when SQL Server 2005 came out, handling dynamic management functions and user-defined table-valued functions were the two main use cases for the apply operator. And for that reason, you can understand why people weren't incredibly excited about it. User-defined functions in SQL Server have always been, well, mired in torpor. Also, dynamic management views and dynamic management functions were brand new in SQL Server 2005, so I don't think people had as full of an understanding and appreciation of them as we now do, so they might have underestimated just how powerful these things are. But if this was the only good use case for the apply operator, I wouldn't be sharing all of this with you. Rest assured, however, that we are just starting to get into interesting use cases for the operator, and in the next video, I'll show you something much more interesting. We'll have links and show notes in the description below, and until we see each other in the next video, take care.